students. Today we will study one important reaction in organic chemistry from the chapter aldehydes and ketones, which is known as Aldol condensation in continuation with the last class. So Aldol condensation is a reaction given by all aldehydes plus ketones which have an alpha hydrogen, when such an aldehyde and ketone which is having an alpha hydrogen is allowed to react with a diluted base. Base could have been, say, a sodium hydroxide, it can be a sodium hydroxide, it can be a potassium hydroxide, it can be a baryta, barium hydroxide, etc. So when an aldehyde or a ketone possessing an alpha hydrogen allowed to react with a diluted base, say sodium hydroxide, potassium hydroxide or baryta, give rise to a resin-like product. A resin-like product is formed, resinous product is formed. And this whole sequence of activity is known as Aldol condensation. Please write it down. So let me tell you again. All aldehydes and ketones which possess an alpha hydrogen, when allowed to react with a diluted base like sodium hydroxide or a potassium hydroxide or even a baryta or any other base, diluted base, they give rise to a resin-like product, and such kind of chemical activity, such kind of chemical sequence of activity is known as Aldol condensation. I will give you one example right now. Just note it down quickly. So if we talk about an example, let us take an example. I have taken an aldehyde. You must be knowing the name of this aldehyde. This is named as what? If you can tell me. This is CH3 and CHO. So this is a simple aldehyde. This is ethanol. Ethanol, this carbon is termed as a carbonyl carbon. The carbon very adjacent, neighboring to this is alpha carbon, and the hydrogen attached to this alpha carbon is known as alpha hydrogen. So ethanol is an aldehyde which is possessing an alpha hydrogen. Now when this aldehyde, 2 moles of this aldehyde is allowed to react with a diluted base, say we take simplest of cases, dilute NaOH, then what we get is, we get something like this. Just look it very carefully. CH3 and CH and OH, CH2 and CHO. A product like this is obtained, and which upon mild heating, is immediately converted into, you have a proton here if you can see. So what happens upon heating, water molecule is lost upon from this, and what we get is CH3 is keeping intact and CH is fine, one hydrogen is lost, one OH is lost, and then there is a double bond, and then CH and then CHO. So this is some kind of, this is carbonyl carbon, this is alpha, this is beta. This is alpha beta unsaturated aldehyde. Alpha beta unsaturated aldehyde. This sequence of reactivity is known as Aldol condensation, in which an ethanol is converted into alpha beta unsaturated aldehyde. Quickly note it down. We have taken 2 moles of ethanol, allowed to react with diluted NaOH. You get a product like this. If you can watch this product.
Now we move to the second part of this lecture, which is the reaction mechanism of aldol condensation.
The reaction, the mechanism of aldol condensation. So check it very clearly and quickly. Mechanism is comprised of 4 steps. Step 1 is, in step 1, what we do is, we take aldehyde. We have taken ethanol in the example, so we'll take ethanol here also. This ethanol is being approached by the base hydroxyl ion, approaches this ethanol molecule, attacks the alpha hydrogen, thereby developing a carbon ion like this. So if you can watch it very carefully, CH2 minus C negative CHO is formed, and this is a highly stable carbon ion because of this kind of enolate ion formation or resonance activity. I said because of resonance, this carbon ion is extremely highly stable, so we get a carbon ion in the step 1. Show it very clearly in your notebook. Is that fine? What we have done is we have taken a base, this is extracted alpha hydrogen, the bonded pair is shifted towards this carbon atom, thereby giving rise to a carbon ion. And why this carbon ion is formed? Because this is extremely resonance stabilized. This is step number 1. So now we will move to step number 2. What happens in step 2? This carbon ion CH2 minus CHO is going to behave as a full-fledged nucleophile, if I can label this as 1 and 2 carbon respectively. So this will attack on another molecule of ethanol. Another molecule of ethanol is being attacked by this carbon ion. The carbonyl carbon, if you can see, is partially positively charged. So this negatively charged carbon behaving as a nucleophile attacks on this positively charged carbon. The pi bond shifts here, and what is obtained, if you can guess, the compound obtained is, if you can label it here as 3 and 4 respectively. So what is happening is 4 is keeping intact. There are 3 hydrogens. Write it very clearly. And then carbon number 3 is shown here. 3. The oxygen atom is carrying a negative charge now. There is a hydrogen, and 3 is kind of attached with carbon number 2. Carbon 2 has 2 hydrogens. So it is keeping intact 2 hydrogen, and then this is attached to carbon number 1, which is carrying an aldehyde functionality. Show it quickly. So the nucleophilic carbon ion is attacking on carbonyl carbon, giving rise to a carbon-carbon bond formation like this. So carbon 3 and carbon 2 are being attached here. Show it very clearly. If you go into the kinetics of this reaction, this is the slowest step in the reaction. So this is referred as rate determining step. Mention this very clearly. This is the rate determining step of aldol condensation reaction. Underline this. This is the rate determining step. Now step 2 is done. We will do step 3 very quickly now. Step 3 is we have carbon 4, we have carbon 3. What else? Carbon 3 is kind of attached with carbon number 2. And what is? Carbon 2 is attached to carbon number 1. Now tell me the bonds and all. CHO here, and then there are 2 hydrogens here, and then there is an O negative here, and then there is a hydrogen, and then there is a CH3. I have made the same molecule here again. This will extract a proton from the solvent. The O negative part will gain a proton from the solvent, and thereby giving rise to a species like this, which you can easily name also. So this is carbon 4, this is carbon 3, this is carbon 2, this is carbon 1. Carbon 1 has an aldehyde functionality. Carbon 2 has 2 hydrogens, if you can see very clearly. Carbon 3 has 1 OH and 1 hydrogen, and carbon 4 has 3 hydrogen. Write it clearly. If we can see this compound could have been named as what? This can be named as 1, 2, 3, 4. This is 3 hydroxy. I would say this is a 3 hydroxy and butanal. Now this 3-hydroxybutanol, when this compound is subjected to mild heating, what happens in step 4? This 3-hydroxybutanol. Write it clear and fast. 3-hydroxybutanol. If you can label the carbon, this is carbon number 1, this is carbon number 2, this is carbon number 3, this is carbon number 4. There are 3 hydrogens, there is 1 hydrogen, 1 OH. So when this 3-hydroxybutanol is subjected to mild heating, this will lose water molecule from here, and what we get is C, and C. This is 1, this is 2, this is 3, this is 4. It's a CH3. There used to be an OH here. Now there is a double bond. There is a hydrogen. There is one more hydrogen, and then there is an aldehyde. So this is a but2enal or 1L. So this is a complete sequence of mechanistic step in the reaction. Till this point, the reaction is referred as Aldol reaction, and after the completion of step 4, which is dehydration, the reaction becomes Aldol condensation. I will repeat again till step number 3. The reaction is referred as Aldol reaction, and after the completion of step number 4, the reaction is termed as Aldol condensation because a water molecule is lost here. You can show it, a water molecule is lost here. So this is the complete mechanism of Aldol condensation. Quickly draw in your copy and revise this. Okay.